So from this lecture we are starting capacity related questions or problems. So one intuition I want to develop is that it is very much obvious, okay, but we can say that capacity, okay, let me denote it by C, or let me write capacity is inversely proportional to number of days taken by a person, okay. So number of or if number of days taken are more, then we can say his or her capacity is less, okay, and vice versa. So with this intuition developed, okay, it is very much obvious thing, okay. So let us calculate the first problem, that A can do 60% more work than B can do in same time, okay. So we can say that A's capacity is more, okay, and it's more by amount of 60%. If A can do work in 80 days, okay, this is 80, then how many days can B do this work, okay. So how to proceed? What we will do, we will write capacity, and from that we will derive days as per this relation that these are inversely proportional. So let us assume that this capacity is 100x, B's capacity is 100x, then A's capacity is 160x because it is 160%, sorry, it is 60% more, okay. So obviously it is 160x. So the capacity, okay, this is in proportion, okay, is given as 8x is to 5x, okay. Note that this is in proportion, okay, because if we cut by 2, okay, that is 20, then we will get this 8x is to 5x in proportion, okay. So the number of days taken will be what? They are inversely proportional, so we can say 1 by 8x and 1 by 5x. Clear? So number of days taken will be 1 by 8x and 1 by 5x, obviously. So but these are in proportion, okay. So if we have to find actual number of days, okay, these are days taken only, then what we have to do, we have to multiply by its LCM, that is LCM of 8 and 5. So multiply it by 40 and this by 40. So what we will get, these are actual days, these are not in proportion now, 5x and 8x, okay. So this is only the trick, that is we can say that whatever we are getting over here, just put it over here, don't do this, just from this only we can say, from this capacity just arrive directly through days, okay. Just I explained you, from next problem we will directly arrive to number of days from this capacity only. So these are number of days which are not in proportion, so number of days taken, okay. So this is 5x is to 8x. Now the question says that if A can do work in 80 days, okay, so we can say that 5x equals to 80. So what is x? 16, okay. This is given data, 5x equals to 80. So question is asking about B. So how many days can B can do this work? So we can now find B, because we know B is 8x now. So 8 into 16. So we know that 16 is the, okay. So I hope it is clear. So this is the answer. Okay. So similarly, we can proceed to next problem, that A's capacity is 40%. So let me write this A and B. Okay. So 40% higher. So similarly, let's say it is 100x. This is capacity only. We are talking about capacity. So it will be 140x. Okay. These are proportional values. Okay. So similarly, we can arrive, that is 7x and 5x. This is capacity. Again, this is capacity only. This is in proportion. So now we will directly arrive to number of days. Okay, just what we have to do, invert these two things. So this is 5x, this is 7x. Now the question is saying, if B can do this work in 40 days, then how many days A can do this work? So we are provided with this data of B, that is 7x is 14, so x is 2. So the question is, what about A? So A is 5x, 5 into 2 is 10. So this is our answer, 10. Okay, 10, 10. Clear? So simple problems. Now let's move towards next higher level. And please note that all the sums which are solved over here are from some competitive examinations only, like GATE. So A can do 50% more work as B. Okay, B alone can do a piece of work in 20 hours. Then in how many hours can A and B finish this work? Okay, so in this problem we will use our that concept also, that stepwise procedure, 3 steps that we have followed. Okay, so first of all is the same thing, A, B, this is capacity C, I'm denoting by C. If B is 100x, then it is 150x because it is 50% more. So in proportion we can write 3x is to 2x. So directly we can arrive to days by this 2x, 3x. Now the question is saying that B can do a piece of work in 20, so 20 hours. So x is 20 by 3. So we can get individual values of A and B now. So A is what? 40 by 3. We get 2x. A is 2x. Okay, this is days. Okay, don't get confused with A, B, C, and D. This is capacity. So this is 40 by 3, and we know B is 20 by 20 given 20 hours. This is hours. Okay, so now we have to calculate that. We know A can do a piece of work in 40 by 3 hours and B can do it 20 hours. So this is conventional question, very first question now, that in how many hours can A and B finish this work. So we can go through that conventional method also, or you can follow this 1 by A plus 1 by B also, that is 3 by 40 plus 1 by 20. Okay, so 22 is 3 plus 2 5 by 40, so it is 40 by 5, that is 8 days. Or you can go conventionally like this, that A then B. Okay, A is 40 by 3 and B is 20. So 1 day work will be what? We have to first find LCM. Clear? So LCM of these two will be LCM of fractions. I hope you are knowing LCM of fractions is nothing but LCM of numerator upon HCF of denominator. So LCM of numerator is 40 and 20, that is 40, and HCF of denominator, that is 1 and 3. You can treat it as 20 by 1. So it is 1 only because these are co-prime numbers. So LCM is 40. So 1 day work will be what? 3. Okay, total work 40 divided by 1 day, this. Okay, so 40 divided by 40 by 3, that is 3. And similarly we will get 2 over here. Okay, so we will get 5 hours when A and B both are working together. We will get 5 hours. So total work is what? 40, and 1 day work is 5 hours. So number of hours we can calculate like this, 40 by 5, that is 8. And conventionally also we are getting that, by short trick also we are getting 8. Okay, so these are two methods. Now A's capacity is 20% less than B's capacity. Same thing, AB. So let's just assume 100x, then it will be 80x. This is capacity. This is number of days we will arrive. So we will arrive directly, okay, as always. So this will be 4x and this will be 5x. So just like this, 5x, 4x. Okay, so the data is saying that A and B together can do the work in 20 days. So we have information about together work. So directly we can equate any 5x or 4x. So now we will go to our conventional method, that is 1 day work. Okay, so 1 day work will be, we know number of days. Okay, so total work we can find. Total work is 20x, LCM of 5x and 4x, nothing but 20x. So A is 5x, B is 4x. So 1 day work will be total by this, so it will be 4, and this will be 20x by 4x, that is 5. So total 1 day work is 9. So what we have to calculate, if both are working together, that's why I calculated this 9. Okay, so because it is provided in our question that if both are working together, then they can do the work in 20 days. So data is provided, that is total work, that is 20 x, that is LCM of, let me write total work also, LCM of 5x and 4x, that is 20x. So 20x divided by 9 will give number of days required when A and B both works together. Okay, these are days. So this 20x by 9 is being provided as 20. So we will get x as 9. Now question is asking not about this 9. Okay, question is asking that in how many days A and B do their work respectively. So now they are asking individual. So simply we have to put x over here and x over here. So A is 5x, so 5 9 is 45, and similarly this will be 4 into 9, it is 36. So these are the respective days of A and B. Okay, so that's all. From next lecture we will use that, we will start that problems in which 4 men and 5 women are involved and such similar kind of problems, and we will use only the short trick. Okay, so stay tuned.